Okay, so we've agreed that we'll do some demonstration and then we continue with the next module. But here is the VirtualBox environment. So I'm going to load my security onion. And like I said, you can get that up by going to your file there in your VirtualBox, and then you locate wherever you have your application. It could be the cyber workstation, it could be the security onion. In my own case, it's the security onion. And I will just go to next, and I'll go to finish, and then I'll wait for a while. Loading. I want to believe everybody passed this stage. Those of us that have not added anything, you can begin to do that right away. By now you'll have done for the cyber workstation. It's the same process, and you wait a while. And those of you who have done this, always note this. You can go to your setting and check your network to be sure that what you have is at the bridge adapter. Please note this, very, very important. Go to your settings under your VirtualBox, because we need to be sure that our system can connect. So while I'm waiting, I want you to be sure, check your cyber workstation and be so sure that you can actually browse on your cyber workstation. I'm probably going to demonstrate that as well while waiting. So this takes a lot of time to load. That's for the security onion. If you have installed the security onion, can you just raise your hand? Let me see. I want to believe a handful of us have done that already. So I'm only demonstrating this so that we can, those of us that have not done that, should be working on that. So I can see Akobon has done that. That means it's good to go with all the practicals. Because once you have all this set up, I don't think you have any more issue. Every other thing is for us to continue to look at the labs and work on the labs. So like I said, check your and see if that is there. And so while the security onion is loading for me, we'll get straight into the cyber workstation and familiarize ourselves with the environment. In the next 30 minutes, I'm going to give every one of us the opportunity to walk through the cyber workstation and then get the activity 1.4 done. I'm going to also demonstrate that here. So if you can see my screen, you agree with me that the security onion is loaded already. Okay, and it's off. So once I double click on it, I'll have it loaded. So here is it. You can have this. So it depends on the strength of your system. If you know the system is not, the memory is low, I would advise you to close as many applications as possible. Okay. Yeah. So I have my security onion setup. So we have it as analyst, and then the password is CyberOps. Okay, correct. So okay, submit. Check this. Okay, let me check out this. Okay. Okay. So let me start away with CyberOps first, and then we walk through the activity 1.1.4. Please, I want everybody to bring up the activity 1.1.4 on your system, and then we could do this together. Please, if you can see my screen, can you just indicate if you can see my screen? Let me be sure you can see my screen. Okay, fine. So Peter can see this. So let's do this. I want to be sure everybody has a cyber workstation. Fine, Bola can say this. So please, you can also load yours. So the username is analyst, and then the password is CyberOps. Check. So we need to check that also for the security onion. Now, this is the cyber workstation. So let's get to the activity 1.1.4. I've already sent all the activity to us. If you do have it, please can you indicate? And if you don't, please also let me know. You can access this directly from your system, your account. So just go straight to where you have your resources, and then you can download all the labs. So activity 1.1.5. Okay. So I'm actually going to send this to us. If you look at this, let me share this first so we can do it. Okay, good. Now this is the activity you all need to start with. Very important. Here is to prepare a computer for virtualization, import a virtual machine into VirtualBox, which we have done. And this is the background scenario. In this scenario, the computing power resources have increased tremendously for over the last 10 years. So a benefit of having a multi-core processor, large amount of RAM is the ability to use virtualization. Meaning that if you don't have enormous RAM, if your RAM's size is small, then there's a need for you to upgrade that. And then these are required resources. You need a minimum of 8 gig of RAM, 40 gig of free disk space. You need a high-speed internet access to download the Oracle VirtualBox and the virtual machine image files. And so you prepare the host for virtualization, which you've done. Download and install VirtualBox. We've done that already. And this is where you can access the VirtualBox. So I advise every one of us, once you click on this link, you're sure to have that. And then when you have downloaded the VirtualBox installation, run the installer and accept the default installation settings. So meaning you don't have to do much, all you just need to do is to go with the default settings. And then here is navigate on the CyberWalk virtual machine on Netacard, download the CyberWalk station and security onion .over image files and know the location of the download. That we've all done, I believe, and if you have not, please indicate. This is one of the labs that actually gives you everything it takes for you to start this this course. So it's advisable everybody should refer to this lab and then get their platform ready. So you all have it, is 1.1.5. So once you have this lab all set up based on the instruction given here, then you don't have a problem. And part 2 says import the virtual machine into the VirtualBox inventory. You will import the virtual machine image into the VirtualBox and start the virtual machine, which you've done. It said open the VirtualBox, click file and import appliance. That's exactly what I just did for the security onion to import the virtual machine image. And then B says if the appliance to import window, specify the location of the over file and click next. So wherever you have the over file for your security onion, just go straight. It could be on your desktop, it could be in your C drive, it could be your external drive, wherever you have it, you just have to load it up from there. And the appliance windows present the settings. suggested in the archive, review the default settings, and change as necessary. Then you click import to continue. So when the import process is complete, you will see the new virtual props. We've passed the stage. Start the virtual machine, which you've done that, and then click the arrow button, and then you go to the check network settings and set your bridge adapter. I want to believe everybody has done that. And if you have issue with that, you let me know. And how do you locate that? I could just go back again and show us that to be sure that we are all on the same page. Now, when you go here, you can actually, you can see my system very well. You go to settings. There in the settings, you can see to your left-hand side, you have all the information here to work with on the virtual box. But then what we needed here is the network. So you can actually use the bridge adapter. In some cases, you cannot if you want, but this instruction says use the bridge adapter. This will help you bridge your system with your real computer, as long as your system is actually browsing. So I want to believe we all are fine with that, and then we go on with that. If you can see my system very well. Good. So it means that we've done justice to that already. And then you move on to getting into the system, the CyberOps stations. We said username is analyst, password is CyberOps. I just did that now, so we're fine. You can try that on your local machine, on your CyberOps stations, and see if that works for you. And step 3, say familiarize yourself with the virtual machine. In other words, show the desktop, the terminal application, the file manager application, the web browser, the file search, current users home directory, and all user applications are located on the applications menu at CyberOps. So list application in the CyberOps menu. So what are the applications we have there? And then it says in the B part, open the terminal emulator application, type IP address at the prompt to determine the IP address of your virtual machine. So we're going to do that and see what are the IP addresses assigned to your virtual machine, locate and launch the web browser, and can you navigate to your favorite search engine, and then shut down the VM, which we're going to do. We're going to shut it down. And once that is done, then you can reboot the process if you want and all that. So let's quickly see how we can just round up this. So I will go to my workstation. Now this is a CyberOps station. This is where you can do a whole lot of this. So you can go to application, like what we just read from the material. Here you can see your run program, you can see your terminal emulator.
So please, I can see your screen.
Oh, really? Can we see my screen?
Yes.
You can see my screen?
I can see it.
I can see it.
Yes, please.
Wow. We can see this.
I can see it, yes.
You can't see it?
I can see.
I can see also.
Then the previous speaker needs to check.
Maybe they can shut down their network card and turn it on again. For me, I can see doctor's screen as he's demonstrating with no issues.
Yeah, probably if you can just
it could
close
be
all the other applications
on their side.
Yeah, but I can hear him clearly, so I'm surprised it's not he's not hearing me. Okay, so like I said, this is where we have the terminal emulator. So if you click on terminal emulator, you have this. Here you can actually set if config to check if you have your IP address. Can you just check your system? Somebody just check and tell me the IP address you have using if config, which remember we were looking at the different commands in Linux. And for you to check your IP address, you use the if config, and that will help you do that. So can you check and see the IP address your system is acquiring, or probably you can ping. Before you ping, you must check to see that the cyber workstation has the ability to connect. You can also do that by checking to see by using can use sudo DHCP CD to check in CyberOps. Let me see. Okay. CyberOps. Okay, fine. Okay, so please, can you just check and see? Okay, I think mine is good. Check to see if yours is fine. And then you can ping.
We have checked.
You can ping, let me see, you can ping 4.4.4. Let me see if that works. So can somebody just tell me the IP address your system is able to acquire, your cyber workstation is able to acquire?
10.0.2.15.
You said?
0.2.15.
Are you sure? So can you just ping 8.8.8? Let's see. Okay, fine. Mine is browsing.
Hello. Hello.
Yeah, can you ping that? Let's see. And you can use Ctrl+C to stop that process.
Yes, Doctor, it is pingable.
Okay, it's going. Yeah, it's fine. And then you can ping google.com. So you just check it out and see. Okay. So I want to believe everybody's fine with that. You can actually check, like last time we said, from the CyberOps stage, you can go to the CyberOps, and then you can see your Wireshark. When you click on the Wireshark, it will load. You can see the Wireshark, my Wireshark is up. Be sure that yours is also working.
Yeah. Is
it working? Just be sure, please. Is it working?
Not found.
Be sure that your Wireshark is working. Please mute your mic, please mute your mic, please. Okay, so just make sure you check all these. This file manager, and you can check your download from here. You can see your file system. From here, you can also the desktop. Just play around this. You can also, if you right click this, you can see you can actually create a URL link. You can create a folder. And you can also change this desktop if you wish. How many of us would wish to change the desktop? And so with this, I can change my own desktop to this. Is it fine? Or you could wish to leave it the same way that we have it. So it's left for you to decide what works best for you. Okay, so I want to believe everybody can ping, everybody is connected with their system, and you don't have any issue. Are we together? And then for your internet, you can launch your browser and check to see if you can actually, let me start a new section. You can check for Google here. Fine, so I can actually search for anything here. CyberOps. Okay. So please, can you just confirm that you're good with this? Because the challenge you have if you don't do this test now is when we'll be doing some of the other practicals, and then you need to fetch data from the cloud, and you need to do one or two things. And so if your connection is poor or probably not working, and you don't have, you cannot connect to the internet from your server workstation, then it will be difficult for you to get the right result. And that's the reason why we all need to check this out and be sure that everything is fine. So I want to believe nobody has issue with this. Is there anyone with any question with regards to this? Before we move on, any questions so far? So I want to believe 100% of everyone here have all this installed. Hello, are we there? Okay, so everybody's fine. So I can see Hada is fine
Yes,
now.
sir.
Oh, lovely. Bernard, you're also fine.
Yeah, doctor.
You're good.
Yes,
Yes.
I'm still having issue with my security onion, so I'm waiting if I can get this done because the network
I
hasn't been
actually
stable over
sent
here.
the server workstation via Google Drive. I don't know if you saw that. I can also send you the
Yes,
security onion
I've seen
too.
it.
Okay, you
Yes,
were able to download that?
So the network is kind of poor over here, so I'm waiting when it's around done to try it and see.
Okay. So I will also share the security onion with you.
Okay, thank you very much.
Yeah, I will do the same and see that you have it. So who else again? I want to believe everybody is fine and we don't have
I
any
have
issue.
issue with the sudo command.
You have issue with the sudo command?
Yeah.
Sudo what? What do you want to do? You sudo DHCP?
Sudo DHCP command not now. Sudo command not now.
Just type sudo, that's sudo space DHCP CD and press enter.
Okay. Okay, thank you. I will try it.
Yeah, I can just try that now and see. Or you want me to share my screen? Can you? And try that and see if it's going to work for you. Okay, so go on and to believe everybody's fine. And can you check your security onion to be sure that it's working for you?
Can you share your screen, sir?
Dr. Dan,
Yeah, let me.
Dr.
Yes.
Dan,
Thank you.
are we
Yeah.
recording this? Are we recording this training?
Yes, it's being recorded.
Please, you will always say, have you sent the former one?
Yes, I
So
have.
that even where I can't see the link where you sent it to because some of us the network is disturbing us.
Oh, really?
Yes.
Actually, there's if you check on the WhatsApp, I don't know if you're there with us on the WhatsApp forum.
I'm not on the WhatsApp, sir.
Oh,
I've
really?
reminded you that please do me a favor. When you add me to this WhatsApp, tell me I need to have a set of the videos. Thank you.
Yeah, you need to do that. Very important.
Let me not break this training. Let's continue. I can always get
Okay.
back.
Okay, thank you very much. I'm going to get you be sure that be rest assured that I'll pass the video across to you.
Thank you,
And
sir.
so you'll be fine. Yeah. But there's no problem. I'm just want to be sure that everybody has installed the virtual box, there's connectivity, because the truth is all the practicals we'll be doing will be on the same platform. The scenario for every practicals are provided, and all we just need to do is to follow the procedure to check and see how it works.
Excuse me, sir. Can I also have the videos too? I mean, right now I am a little way behind what is happening. So if it is possible to share the video too, just as Julius wanted, if I can get it, that would also be nice for me to. Yeah.
Okay. Hey, I need to find out this. As long as you're on the WhatsApp group, you should be having the videos. Those of us who are on the group, are we not getting the videos? Hello. So
Hello?
what you do for me, please, is
Yes, we are getting, doctor. If we
okay,
are,
fine.
I am not on the WhatsApp group, so I'm not getting it.
Yeah, and then
I am not also on the WhatsApp, so
so
I'm
how
not
did you
also
get
getting
how did you get to this platform? Because the truth is, you just have to be for everyone to send that mail to. There was a link for you to click on to get into the WhatsApp groups. Probably if you get back to the email again, you can actually find the link there. But once you click on that link, it takes you to the group.
Doctor,
But it's not a
remember,
problem.
mine was
Since
not through the email. Sorry, doctor, mine was not through the email. Am I right?
yeah, so what I'll do for us is this. I'm going to share us the link again. So all you just need to do is on the chat here, just come to the chat and provide me your email address again, and then I'll just send that to you.
Thank you,
Is
doctor.
that okay?
Yeah.
So as many of us that are not on the platform, kindly just send me your email and I'll just broadcast that to you. Okay, I think that if you come online, all the videos, the previous videos, I'm going to send them all over again. And then the link for you to download the VirtualBox, the cyber workstations, the security onion, they are all there. And then the procedure for installing them are also there in the video. So even today's video is currently recording, and once we're done, I'm going to post it immediately to the same forum so that you can go through and then just play around the application. So quickly we get to module 5. The truth is that module 1 is talking about the threat actors. Module 2 will just take you through the SOC, that's the Security Operations Center. Module 3 we begin to talk about the operating system, that is Windows, and then help us to look at the vulnerabilities of Windows, as the case may be, and that we will also see. And there's a practical that you also need to do for Windows. And actually that a lot has to do with your system, where you use Task Manager and all that to check processes and to store some of the activities on your system. So I would advise everybody should begin to work on those practicals. If you have any challenge, feel free. What I'm going to be doing now is once I get concluded with this first week, by the following week, all the practicals we need to do for this, we just play around those practicals and then we move on. The major practicals for this particular course, you begin to see them happen when you get to module 10. For network protocols, most of them actually are for folks who will have done the CCNA1. But I'll try as much as possible to explain some of these concepts in this course, in as much as they are supposed to be treated in CCNA1 and 2. And so the main cyber topics, you start seeing them from module 9, 10, and above. So it means that what we're doing right now, we're still at the introductory level of the CyberOps. So please take your time to watch the video and then go through the material, because once you're already enrolled into the platform, you should be able to gain access to resources. And then even the applications you need to download, they are all there on the platform. So please go on with that. And then if you have any issue, you can private chat me and I'll assist you. For module 4 that we're looking at yesterday, a whole lot of them will do them as labs, because when it comes to Linux, you just have to practice with it in that environment. And the good news for you is that the cyber workstation is all about the Linux environment. So all the commands can be practiced in there. And so the labs associated to Linux will also be treated there. So I will also take the whole of Tuesday next week. So do as many practicals as possible. And these practicals are actually very short practicals. You can see we just talked about the lab 1.1.5. you can see how straightforward it is. And that is all you need to do for the subsequent labs. The scenario are there, the procedure for carrying those labs are there. Once you get to do them, you just get the right results. The main thing is to carry out the interpretation. So for every labs you do, you must know the interpretation so that you can be able to teach your student when it's time. And so today we just quickly look at the network protocols. For network protocols, you agree with me that it has to do with how systems are connected and resources are being shared. The major objective here is to explain the basic operation of data network communication. Explain how protocols enable network operations, and then we'll look at how data encapsulations allow data to be transported across the network. These are the major things we're going to cover under this module. So quickly, we'll look at network communication processes. First, you agree with me that the network vary in size from your LAN, your WAN, and all that, and it grows into millions of devices. And then business and large organizations use network to provide consultation. They store their data, and they also use it to transmit data from one point to the other. And then we have peer-to-peer network. Actually, this is in a small business and home. They use this majorly. And then many computers function as both the servers and clients on the network. So you could have peer-to-peer network connection. In this case, any of the system can assume the server and the client at the same time. Okay, so these are the network of many sizes. You have it from small home network to small office and home office networks. All this to show you that you can actually look at expansion of network from when it's small and when it's big. But then we have categorization for them. You have medium to large networks, and then you have the worldwide network. And that is where you have the internet. So the internet also can be seen as a worldwide network. And then we have client and client to server communications. And this is where you have the client communicating with the server. In summary, the client initiates requests while the server responds to requests. So once an application is any system and somebody is initiating request to that system, the system that responds to that request is more or less taking the position of the server, meaning that that is where the application is. And you agree with me that when you use Wireshark, for instance, on a network, you could see a direction of where all the traffics are heading to. You can see all the TCP headers. You can see on the destination part, you just see the same kind of IP addresses across board. That is the server. That is where all requests is being channeled to. So, and that is where the hacker, and that's why some of these network tools we use in CyberOps, hackers also use them, because what you use to carry out the investigation, you use to do penetration testing, the hacker also use them also to carry out their own testing and all that. But for you as a CyberOps analyst, your job is to use it to actually get to know some of these early warnings, and so that you can mitigate against them. If you recall in Module 2, where we talked about the role of the SOCs, I mean the different tiers under SOCs, you agree with me that we have them in different categorization. So we have those who just do normal monitoring, and then we have the analysts who we also have the hunters. The hunters are the ones who in the tier of the cyber in the SOC, they are the ones who detect, they carry out mitigation, they ensure that once they detect any abnormalities, they make sure it's being removed from the network even before the harm happens. So that is a trend for the CyberOps, and that's why all these tools are used. Now here we're discussing network, and the reason why we want you to understand network is because all the resources, all the information actually are being transmitted across the network. So the server is a very sensitive component when it comes to its position, because that is where all the sensitive information are archived. So here you can see a client-server communication. You can see the file server stores corporate and then user files. In this case, you can see the email client. You can see the email server. So the client talks to the email server. You can see the web server. You can see the web client, meaning that this is pointing to the web server. And then you can see the switch here. You can also see the file server and then the file client. This is just to let you know the number of activities happening between the client and the server. And this is a typical section. In a typical network, user normally uses some type of computing devices to establish many connections with network servers, and those servers could be located in the same room or around the world. So at schools, students are encouraged to use devices such as laptops and tablets to access learning resources. In summary, the essence of having a network is to share resources and have access for communication. And so this is a game to demonstrate that process. And then tracing the path. Cybersecurity analysts need to have a deep understanding of how networks operate. They must be able to determine the origin of traffic and its destination. And traffic comes from a computer to an internet server, can take many paths. So you see here, it is very clear that the essence of learning computer network here is to be able to see that you know the source of a packet or a traffic, and then the destination. The source is where is this coming from and where is this heading to. This is a private IP address. This is local inside, and this is a public IP address. It could be local outside, or it could be public inside. So you just need to understand the thin line between when this computer is actually domiciled in your own intranet system and the one that is domiciled in another network outside your domain. And probably that is the destination device where you're sending information to. And one of the best tools you can use Wireshark to establish that connectivity. You can even use ping plotter. In some cases, ping plotter is another special tools on the network to tell the different hubs away. You know, the good thing about ping plotter is that it gives you a very clear view of the different routers in that connection from the source to the destination. Sometimes it even tells you the source where the ISP is and the number of hops away. So all these tools actually help you to have a clear understanding of what is happening on the network. And so tracing the path, a combination of copper and fiber optic cables that go over land and under the ocean carry data traffic. So these connections connect telecommunications facilities and ISP distributed throughout the world. So you agree with me on this, that it could either your connection could be through cable, it could be through fiber optic, it could be through satellite, and all is just to get to create end-to-end connectivity. So the global tier 1 and tier 2 ISP connect portion of the internet together, usually through an internet exchange point, which is the IXP. So you can see more or less what we also refer as teleport, where you have a convergence of this connection from an ISP. So layer network connect to tier 2 network through a point of presence, which is the POP, which is usually a location in the building where physical connection to the ISP are made. The tier 3 ISPs connect homes and business to the internet. So more or less like the MTN in Nigeria, for instance, they can stand in this position. Intelsat, company like Intelsat in the US, like GLAT, can take the position of tier 1. So this gives you a kind of a clear understanding of how the ISP is structured. Now here's a lab. In this lab, meaning that as you read through the content, a candidate expected to do this lab. And what are you going to do here? You will use 2 route tracing utilities to examine the internet pathway to destination network. The objective will be to verify connectivity to a website, use the trace route utility to the Linux command line, and then use a web-based trace route tool. And the lab here, all these labs are actually in the lab I shared with us. If you have the student labs I actually gave, we have it there. All the labs are there that you're going to do. And communication protocols. What are protocols? As protocols are a set of rules or tasks guiding a particular operation. So simply having a connection between end devices is not enough to enable communication. For communication to occur, devices must know how to communicate. And so that means there are laid down procedure or principle to ensure that devices communicate effectively. So you can see to your right-hand side the protocols. You have the encoding, you have the encapsulation, you have the message size, you have message timing, you have delivery options. And these are all protocols that have to be followed. So these protocols are specific to the type of communication method occurring. Network protocols specify many features of the network communication. And this, in summary, make us understand that everything that happens on the network must happen based on protocol. So that means for communication to move from point A to point B, based on demand or based on the services, it must go through certain protocols. For instance, if you're sending a voice, probably it could be video via the internet, you must use the UDP, which is the user datagram protocol. That is the pathway for such kind of activity. And then if you're using your normal text and whatever, it has to go through the TCP. So you can see TCP, so transmission control protocol. So everything on the network goes around the protocol. So you can see here, we're saying that under the protocol, you can see encoding, which is the, you see this at the presentation layer, mostly where encoding, decoding takes place. And then you have encapsulation. Encapsulation is that whole process where you have your data broken down into segment, into packet, into frame and bit. That is the encapsulation process. And every message must have size. And here you agree with me, it's what we call flow control and windowing, where you're going to see the size of packets that must be transmitted across the network. So there's a protocol also that must govern the size of packet that must be transmitted at every point in time. So when you send massive information on the internet does not just carry them. What the internet does is that it breaks down this data into what we call segments. And these segments will all have headers. And then when it gets to destination, it all reassemble and then give you your full data once again. And you could see that it at different layers, it takes a different form, which is what we call the PDU. That's a protocol data unit. So this tells you that data change in form as it's being transmitted across the network. And these changes at different stages are being governed by different protocols. So network protocol provide the means of computers to communicate on network. It also dictates the message encoding, formatting, encapsulation, size, timing, and delivery options. The delivery option is which option is it working with? Is it which kind of file format? Which is it TCP? Is it UDP? As the case may be. So some common networking protocols are the hypertext protocol, which is the HTTP, and then you have the TCP, like we mentioned earlier, and then the Internet protocol. Note, in this course refers to both IPv4. So when we say IP, we're referring to the IPv4 and IPv6. IPv6 is the most recent version of IP and we eventually replaced the more common IPv4. So here you can see network protocols in terms of the structure and then in terms of the path sharing. And in terms of the structure, if you look closely, you just see a demonstration to show you how these routers are connected and then from the client to the server. I will send this message across the network using an IPv4. That's the header from the client. And then at the destination, it said, I can accept this message because I understand IPv4. So you can see that there must be some form of understanding between the source and the destination for the channel to be able to carry the information and then transmit it to the end devices or to the destination device. And then if you look at the right-hand side where you have path sharing, this actually specifies the process by which networking devices share information about pathways with other network. And this is where decisions are made. And then here we can have different types of routing protocols to determine which best path to take. And that is one of the major functions of a router. And so here you can see information sharing. I specify how when error system messages are passed between devices. And then here we also have section management, which manages the setup and termination of data transfer section. So these are all protocols that tells you the behavior of data as it's been transmitted from one hop to the other on the network. And then here we have the TCP/IP. This is a major protocol standard, what we call protocol suite, TCP/IP model. If you look to your right, you agree with me that you can see the application layer, the transport layer, the internet layer, and the network access layer. So at the network access layer, this is where you have both your data link and your physical layer. This is the TCP/IP protocol. If you really want to understand this better, you also put it side by side with the OSI model. And then at the internet, you can see the major thing you need to note here is the IPv4 and IPv6. That's what happens here at the internet layer. And then at the transport layer, you have the TCP and the UDP. And then at the application layer, you can see we have the different protocols here, like your HTTP, HTTPS, your FTP, your SFTP, TFTP. These are well-known port numbers that have their numbers, like your SFTP port 25, POP3, port 110, your IMAP, your FTP, your SFTP, TFTP for trival. That's when you are actually in some cases updating your iOS of your router. Now, all these examples is just to show you that there's a standard, and this standard is a measure to tell you how data is being transmitted across the network. So this is a standard that is being followed. This was put together by the DoD, which is the Department of Defense during the World War, as a way of trying to get to their base station. But the industry standard is the OSI model. And so still on the TCP/IP, and then just go ahead and still on the transport layer. The transport layer is still a component of the TCP/IP, and it helps to maintain end-to-end data integrity. You agree with me that it has two pathways, either the TCP or the UDP, which I've actually explained earlier. Here we have Internet protocol. Please also note, this is still under the TCP/IP. The TCP/IP, like we said, has 4 layers. It has the application, it has the transport, it has the internet, and the network access. So what we're looking at here is the different layers and what they do. So here is that in the internet layer, and then we could, if you still recall, we have it as IPv4 and IPv6. And the NAT here is the ability to be able to connect your private network to your public network. Okay, and still on the TCP/IP protocol, you can see here the ICMP, yes, your Internet Control Message Protocol. This oftentimes you use it when you ping. So most of us, when you ping and you're trying to test connectivity, like when we're trying to check the behavior of the cyber workstation, we actually pinged, We pinged 8.8.8, which is Google, and we could see that it was replying. And that's why I said everyone should test it on their system, be sure that it's working, so that all the labs you'll be doing, you'll be sure you can get it in real time. So when you ping, you're actually using the ICMP, which is the Internet Control Message Protocol. When it comes to the routing protocols, note this: routers makes decision. Routers are the key devices on our network. They are the one that administrate over our LAN. So everything about connectivity in an enterprise, for instance, one of the major components or the major networking devices that manages IP addresses is a router. And this router makes certain decisions on how it can transmit data. Remember, when you're sending information from your enterprise network, from your organization, your institution, outside your network, the router must make a decision. And that decision the router will make is which part will it take. So the router has several decisions to make. And one of the ways is there must be a concept. So you as the administrator will configure the router to either use the OSPF, to use the ERGRP, or to use RIP. And so whichever protocol you decide to use, we are saying that those protocols have certain metrics or parameters that guide them. So here in the routing protocol, you see OSPF. OSPF is Open Shortest Path First, and it uses the link state routing protocol concept, which is it transmits its data based on the speed. So speed is one of the major metrics, what we call cost, that OSPF uses to make or transmit or make its own decision. Then we have what we call the EIGRP, which is the Enhanced Interior Gateway Routing Protocol. This is actually a distance vector routing protocol, and it's actually a Cisco proprietary routing protocol. So that means Cisco owns this, but then it's actually part of the distance vector routing protocol. And then we have the BGP, the Border Gateway Routing Protocol, and open standard exterior gateway routing protocols used between internet service providers. That means if you have two internet service providers, you can use the BGP to connect the two of them.
Sometimes he might be okay with it.
Please, you can mute your mic if you're not with us here listening to us. Kindly mute your mic, please. So we have the network access layer. The network access layer actually that is the last layer of the TCP/IP model, and it provides dynamic address mapping between an IPv4 address and a hardware address. Yes, please.
Dr. Dan, sorry, we need to call that fellow that is disturbing us. Maybe call her by name or him by name. Maybe we know.
That is Kweku.
Talking a little bit about
Hello, Kweku. Can you just mute your mic? Okay. Some of us will just connect and then we will just okay.
Something else.
Yeah, and that's not proper. Okay, so here is the network access layer. On the TCP/IP model, you agree with me that the network access layer is actually at the tail end of the model. And what does it do? It has both your data link layer and your physical layer. And it uses what we call the ARP, which is the address resolution protocol, to provide dynamic address mapping between an IPv4 address and a hardware address. The hardware address, which is a MAC address. And the data link protocol uses your Ethernet. Remember, your Ethernet is that connectivity between your cable and probably your NIC. That's where you have your Ethernet, and then your wireless LAN, still under the data link layer, which is a wireless local area network, is for wireless signaling across the 2.4 to 5 gigahertz radio frequency. Now, this is a band, this is the radio frequency or the wireless signal frequency for wireless LAN within 2.4 and 5 gigahertz. And recall that it has channels, and some of the channels are actually overlapping channels, and then the non-overlapping channels. So you need to note this, very, very important. And the reason why I also do this is for us to have a very good concept of a wireless network, and then also look at the vulnerabilities when it comes to wireless network. So message formatting and encapsulation. When a message is sent from source to destination, it must use a specific format, which we agree, and that comes in the kind of file format. And message format depend on the type of message and the channel that is used to deliver the message. Which channel? Is it a video file? Is it a voice file? Whichever file, it must go through a channel. And that channel could either be your TCP, UDP, and in some cases, your presentation layer, which takes care of different file formats, will also play a major role. You agree with me that you can have file format like your JPEG, PNG, and all that. But here we're looking at encapsulation. And the term encapsulation when it comes to networking is the change of data from one layer to the other. But recall that at the end of the day, the change of this data, it must reassemble to form one data still. So that means that everything that is transmitted must be broken down into that smaller form. So message formatting and encapsulation still. So the analogy is when sending a letter, correct format is required. An envelope has the address of the sender and receiver, as in real world, and each located at the proper place on the envelope. So that means in real world, this is what we do. And also in the computer world, is the same thing. So when you send a letter, the letter must carry a format, and the letter must carry a source, which is like an IP address, and must carry the destination address, which is the IP address of that system. So the process of placing one message format inside another message format is called encapsulation. So the issue here is that it is still data. The data is being enveloped or placed inside a header. And that header is like changing the whole format, because the subsequent layers must treat this data differently. That's why if you open a frame, inside a frame is a data. If you open a packet, inside a packet is a data. So this is just to let you know that from this analogy is just to tell you that when you write a letter, you put that letter inside an envelope. But that letter is the main content. So data is actually inside an envelope, in this case, which could be in frame, which could be in packet, which could be in sequence. And that is the explanation here. So de-encapsulation occurs when that envelope is removed. So remember that at the time when it is going to be received by the destination device, it's going to actually remove that envelope and check what it is finally. So when a source device or a system sends an information, that system sends information as it goes through the network have a way of enveloping that data, so that subsequent layers must re-envelope it on their own. So that enveloping a data from one layer to the other is the encapsulation. But at the point where it is leaving the last layer and will be received by the system will take off that envelope because the system is interested in the data. And that process of taking off the encapsulated file format is called de-encapsulation. So we need to understand the difference between encapsulation and de-encapsulation. So network, similar to serving a letter, a message that is sent over a complex network has to follow specific rules. And those are the rules we have actually explained here. So if you look at the right-hand side, you can see more or less the architecture of a typical message format in an IP address. So you can see the source, you can see the destination. But if you put that together, it forms 4 bytes, which is 32-bit length. And you can see that for the first byte is actually the version and the traffic class, and then the flow label. All this is just to give you a complete length of the IP address, which is 32-bit length. So IP is responsible for sending the message from the message source to destination over one or more network. And that's why we need to have very clear understanding of IP address. So we also explain this analogy of communication between 2 persons. And that two persons can actually be seen between two systems. So here we're looking at network, and coding between hosts must be in an appropriate format for the medium. So messages sent across the network are first converted into bits and then being sent across the network. So each bit is encoded into a pattern of sound, light wave. So at the point where it is leaving one whole network to another from a network, it can either go through light, which is a case of fiber optics, or it could go through cable, copper cable, or through satellite. Remember, when it's going through fiber optic, it's through light. So the signal for light is that differs from your copper cable. And that, if you're going via light, it's going with the speed of light. And the speed of light is about 3 times 10 to the power of 8. That tells you about 300 meters per second, 300,000 meters per second, which you can also take as 300,000 kilometers per second. So 300 million meters per second, or you have it as 300,000 kilometers per second. That's the transmission of light. And that's the same speed in which data is being transmitted across the fiber optic. So it could also go with what we call flow control. And flow control, this majorly happen in your TCP. And then the response timeout, that means the time it takes for response. Because when you are trying to talk to somebody, you talk and then it has to go through a channel and the person hears you and responds back. So in the case of a network, the same thing. It has to go through the channel and then there must be a response from your other end. And then we have the access method. This is determining when someone can send a message when a device wants to transmit on the wireless LAN. It's necessary for the wireless LAN link to determine whether the wireless medium is available or not. And so we have different means of transmitting when it comes to network communication protocols. So unicast is when you're sending from one to one. Multicast is when you're sending to group of targeted system. And then broadcast is when you're sending to many systems at the same time. So one is one-to-one system, one to targeted system or group of systems, and then the other is to all. So you can see that. And then what's the benefit of using a layered model? One, it assists in protocol design. It helps in design. So you can see what's the layer model you're talking about, either the OSI model or the TCP/IP model. Why do we need this? Why do we always talk about application layer, internet, network? Why? So this is the reason. The reason is what you have to your left. It is assisting in protocol design. It helps design protocols. It helps industry to maintain certain standard. It helps all us. It helps us to be able to tell what role is happening at what point and which layer should be responsible for which particular kind of fault. And that's why when you're doing your troubleshooting on your network, you work with the OSI model. It goes a long way to help you, you know. And then fostering for competition, preventing technology or capability changes, and then providing common language. So the two-layer models, like we've explained, is either the OSI reference model, which is what you can see here as the 7 layers, or your TCP/IP reference model, which is what you can see at the right-hand end. So you can see they are all the same, just that for the TCP/IP, the application takes care of these 3, which is the upper layer of the OSI model. And then transport is still transport. Internet is network for IP, for OSI model. And then you can see your network access here under your TCP is what you have as a data link layer, and then your physical layer. So that's it. And then the OSI reference model I've explained is put together by the industry as a standard to be able to checkmate how communication works. So you can see all the OSI model here, that's from layer 1 to 7, and their function. The application protocol used for process to process communication, the opposition transferred between application layer service, and then you can see a section which provides services to the position layer, and then your transport, which actually maintain end-to-end data integrity, and then your network that provides service to exchange, and then your data link layer, which also is where you have your MAC address and it does error detection and correction. And then you have your physical layer, which you have, in this case, it has to be with your bit in zeros and ones, and then that's where you have cable and your radio, but even your hub also belongs to that layer. Same also we have for the TCP/IP model, which we've explained, and then let's quickly look at data encapsulation. So we've explained what encapsulation is in summary. I recall I said encapsulation is the manner in which data is broken into different forms. And then here you can see that this is segmentation, and then this happens at a transport layer. So it's a way of having a large stream of data broken into that form. So you can see it's a process of dividing a stream of data into smaller units. So when data is broken down into smaller, in other words, encapsulated into that form. So you can see segments of data as data still. It's just the header, which is like the envelope we're talking about in real life. Okay. And then what is the benefit of segmenting data? It's increased speed, it's increased efficiency because it will be easier to be transmitted. And then we have sequencing. Sequencing happens most in TCP/IP. Is while transmitting message using segmentation and multiplexing, there's a possibility of data to reach the destination in a collapsed order. So each segment of message must go through what we call a sequencing process to ensure that it gets to the correct destination and can be reassembled similar to the content of the original message. So your TCP is responsible for sequencing the individual segment. And that's why sequencing only happens in TCP. You don't have sequencing in UDP. And we have talked about the PDU. I've said PDU is the unit of data as it moves from one layer to the other. And then here we have the protocol data unit still. For each form of data, the general term for PDU used at the application layer. And for segment, it is known as, at the transport layer, it is known as segment. At the network layer is known as packet. And at the data link layer is known as your frame. And then at the physical layer, it is known as your bits. So recall that is the unit. That means this is a unit of data at each particular level. So we have three addresses when it comes to the encapsulation. You can see the protocol address, which happens at the transport layer, and then the network host address, and then we have the physical address. So network protocol require addresses to be used to network communication. And then for your network host addresses, that is where you begin to look at your IP addresses and all. And then the transport layer uses protocol addresses in the form of port numbers. So that's where port numbers comes in. So you could have port 23, your telnet, you can have your FTP for 21, 22, 2021, and then you can have your SSH 22. So you have all these web port numbers, and that's what the transport layer does most to ensure that you have these port numbers for most services. And then the network layer specifies addresses that identify the network, which is your IP4 and IPv6. And then your data link layers actually specify the relay devices on the local area network that should be handled on data frame. Remember that what you have as PDU on the data link layer is your frame. So all three addresses are required for client-server communication. So you need these three addresses every time, any day. And that once you understand these three addresses, you understand communication network more effectively. So this is an encapsulation example, how it works from the user data to TCP to packet and then to frame. And remember, after frame, you have it in bits. I've explained the encapsulation, and I said at the point the system is to receive the data, it has to carry out a process called the data encapsulation. So there's a lab for us to do, which is using the Wireshark software protocol analyzer, packet sniffer application used for network troubleshooting analysis and software development and education. In this lab, you use Wireshark to capture and analyze network traffic. Here you have this Wireshark inside the cyber workstation. You can also play with that. So what we'll do is that I'm going to put list of practicals we'll just do on Tuesday. We'll just walk through them on the same cyber workstations and see how that works. Remember, you can locate your Wireshark inside the cyber workstation. You can also install it on the system. So I've explained the data encapsulation and then network protocol summary. So here in summary, we've learned all this. We'll look at network that we believe they come in different sizes as home, for businesses, and for position. We'll also look at server and client. We'll also look at large businesses. We'll look at ISP from the port of teleport, looking at them at different tiers, and then showing that they are all interconnected. And then we'll also talk about network protocols. We'll look at how network communication happens in terms of encoding, message formatting, encapsulation, and delivery option. So we've explored all these in the course of this module. And I want to, at this point, pause and then give us room for questions. So do we have questions so that I can react to them? Any question? Any question? Hello, are we here?
Yes,
lost us.
We are there.
Yes.
Okay. So any question? So I want to respond to question. We actually have a Cisco instructor forum today. I don't know, Mr. Julius and some of you that I'm seeing here are supposed to be there as well. So after the question, so we can pause for today, and I'll send a recording, and then we continue. But please, all assessment has been activated for you to take, and so that we don't have so many assessments hanging behind. And the labs are also available for you to practice. Like I said, we'll be practicing some of them here while you'll be doing yours as well. You have to follow them stage by stage. And like I said, for the topics we've covered, like this week now, it's expected that you do all your labs to module 5 and send to me. So between now and Tuesday next week, I should have all your labs for module 1 to 5. If you're having difficulty, there's no problem. As I come online on Tuesday, you can tell me, oh, I was doing this, I had this issue, I had that issue, and all that. We'll put that together. And that's the essence of learning, and that's the essence why you're here. But if you're able to do that hitch-free, no issues, no cause for alarm, you can just have it. Like I said, for every week I have to grade you, and I put the grading system. So it's wise you do the practicals. You don't need to leave it and wait until when the time is over. So any question? Okay, can say no question. We're all fine. So I'm going to make the recording available. I'll send it to you. Okay, go ahead. Go ahead.
Yes, sir. Actually, I missed the class yesterday, but I listened to the recording due to network issues. But what I gathered, you said those of us that have not been able, I was unable to still load my VM, sir. So I'm still working on it, sir. That's what I want to say.
Okay, sir. Kindly private chat me and let me know the challenges you have. If I need to come online to resolve yours, it's fine. I'll do that.
Okay, sir. Thank you so very much, sir.
You're welcome.
Yeah, Dr. Daniel.
Yes, I'm with you, Peter.
So with the Google Drive you sent, it seems you have to make the access. You have to unlock the access for us, because we have to like send you the request form before you be able to get access to it.
Oh, sorry about that. I'm going to allow for everyone to access it. Sorry.
And I don't know if, let's say, you can combine the CyberOps and the
okay, fine. I could just put all of that. If I put all in one folder, it will be very heavy. So I'll share them individually so that If your network is not good, you can download them separately. So I'll do the same and then make sure the permission is granted for all.
Thank you very much. I'm much grateful.
Thank you, sir.
You're welcome. Yeah, thank you, sir. Okay, so I will just, when I end this, I'll share the recording and I just advise you go through it and then go through. I also send the PowerPoint for this particular module as well, so that you can walk through the PowerPoint while you're listening to the recording. And then kindly go into the your account and read through and then take your assessment and possibly take your labs for the period that's from module 1 to 5. And then you send them to me by my email. I'm going to also post my email to the forum again for those of you who just joined. And for
I think
Mr.
your email,
Julius,
somebody sent it on the
I think
platform.
I'll send it to the forum again. I'll post it to the forum.
Okay.
Yes. So when you check the forum, you see it right away. I'm doing that now. So you can use it to send. Please, like I said, you have any challenges, feel free to let me know. Okay.
Hello,
So
Dr.
I've seen,
Daniel.
yes, yes.
So I'm asking for online assessment. How
Yeah,
much
the
will you
assessment, I just reactivated the assessment now and then re-enable it for as many that wants to retake.
For how many days?
You said?
For how many days the assessment will be available today?
I said for everyone. I reactivated for everyone.
For 1 week available online? Just 1 day?
Yes. Okay, whatever it is, just private chat me, screenshot, and then let me see if you have any issue.
Okay.
I just did the reactivation again before this class, so you can check.
Okay, thank you.
You're welcome. Okay, so see you guys virtually next week, Tuesday. And if you have any issue before then, you can private chat me or you can post it to the group and we can react to them.
Doctor.
You say?
Dr. Dan, yes, I'm here. May I ask about something, please, before we leave? So yesterday you said we have to send labs from module 1 to 3 before the end of this week, right? And now you are saying that we have to send from labs from module 1 to 5 before the next session, next Tuesday. So what will we do?
Yeah,
well, together,
do the
1 to
much
5?
you can do, but it's just that as the week goes by, it will be nice we get all the modules, all the labs done. Just do the much you can. But for this, yes, if you can do all of them, you can send it. That's perfect. You can send it. But
okay, fine.
actually, I said for module 1. But between now and Tuesday, you have a lot of time. Tomorrow is Friday, there's Saturday, there's Sunday, so you can start working on them. The labs are not much. If you just check, they are not much. So just go through the labs and see. If it's much, I could extend the period. If you think it's too much for you. Yeah.
Okay, fine.
Yeah.
Much appreciated.
Okay then. Okay, so see you guys virtually on Tuesday next week. But please do the much you can and keep me posted if you have any issue. So Peter,
thank you.
I'm going to share that with you. Yeah.
Okay, thank you very much. Thank you.
Thank you, sir. Bye.